Hello, this is Wim again. Today we're going to talk about passive and active microwave remote sensing. Microwave remote sensing is remote sensing that uses the electromagnetic spectrum in the 2 to 1 meter wavelengths section of the spectrum. So it's really a very different technique and technology that allows us to look at again, like the world with a different perspective. The passive and active microwave sensing is also allowing us to actually, especially with the active part, to look through clouds, basically. And so if you have a tropical forest and you want to observe that forest, there's a lot of cloud cover, you actually, with microwave remote sensing can penetrate those clouds and actually look at the surface. So microwave allows us to look at soil moisture, look at plants. The moisture basically in the plants and in the soil really determines the signal that we get from microwave remote sensing. So we talk about the dielectric constant. The dielectric constant of water is really high, so that really determines the backscatter that's coming from a pulse that was sent out by a microwave transmitter. When it comes back, the water at the surface will determine how intense that signal is coming back. So we'll also can look at passive remote sensing and microwave remote sensing, and that's when we talk about emission. It's actually a really weak signal, and quite often the pixels of these weaker signals have to be much larger to actually get a good signal to noise ratio. So passive is basically emission of radiation in the microwave region, while active is basically backscatter from a particular region. So there's many applications again, and I hope that you'll learn about a lot of these applications. There's other techniques that look at topography as well using microwave, like with the topography mission from the shuttle. It uses 2 sensors, and then the 2 sensors allowed us to create a digital elevation model, where what they call interferometry, they use these 2 sensors to create a topographic model. There's a variety of other synthetic aperture radars that have been used to look at the land surface, and it's really about trying to figure out basically the right wavelengths quite often too, that the longer wavelength will penetrate more of the vegetation and even dry soil. They actually go and maybe find dry rivers under the sand. The shorter wavelengths will not penetrate as far. So that's another one of these things that you kind of have to evaluate which of the sensors you want to use for that. In terms of what we're going to do this week, you're going to look at the problem set, going to do some calculations, and for the lab, I decided to give you a tutorial that was developed by the SMAP team, the Soil Moisture Active Passive team that of a satellite that was just launched. SMAP is a dual sensor, passive and active. The active sensor is actually currently broken, but we hopefully that it gets recovered quickly. But the tutorial will allow you to download a soil moisture and freeze-thaw data set that has applications for ag and carbon and drought and flood monitoring. And we're going to have you download some data sets and some software that allows you to display these data sets. So enjoy the microwave topic this week, and I'll talk to you soon. Take care.